Okay, so now let's talk about how the above approach has been implemented. The implementation consists mainly of three main things: VR platform hardware, VR platform software, and a checklist module. The VR platform hardware consists of two projection design f2 video projectors fitted with two optical filters, a 3 meters high and a 2.25 meters wide stereo projection screen, several pairs of 3D glasses. The second component of the hardware is the haptic system. The haptic system is composed of two elements: a virtual 6D 3545 haptic arm and a control PC. The haptic arm is a sensory motor bidirectional interface which allows manipulation by the user and force feedback. For people who are not familiar with an haptic system, think of it like a Wii controller. The third component is a CyberGlove 2 wireless motion capture data glove, which uses proprietary resistive bend sensing technology to provide in real time 22 joint angle measurements. And the fourth component is an AR track infrared motion capture system, which is composed of 4 IR cameras and 6 sets of targets, as well as a control PC. It provides in real time 3D positioning and orientation of any target. Now coming to the software components, the virtual environments manipulated and explored are based on 3D CAD models generated with standard CAD tools. Modules have been implemented as scripts using the Virtuals environment for interactive simulations. 3 levels of development provided by Virtuals have been used. Level 1, which is the top graphical level. Level 2, which includes the virtual scripting language that allows the programmers to build specially tailored building blocks. And level 3 is a C language software development kit. Virtuals is used to endow CAD objects with properties used in interactive simulations. The third element is the interactive checklist. The checklist has been written as an Excel worksheet. This format serves as both input and output for storage. So the checklist module itself opens the Excel file, it imports the data and builds the corresponding tree architecture in the Virtuals environment. Then different levels of the tree are displayed as interactive menus. And when a question is selected, the associated 3D virtual environment is launched. During the virtual experiment, the operator can start video or snapshot recording. When a question has been checked, an answer is stored in the Excel sheet and it's linked dynamically to the multimedia data related to the virtual experiment. So now we look at the experimental results. So we will see 3 separate videos. The first video is going to illustrate the use of the gesture recognition system for checklist navigation. First, the hand posture calibration procedure is shown. Next, each navigation functionality, including posture 1 through 5, will be demonstrated. Posture 1 is to validate an item or a question. Posture 2 is to step back in the checklist tree. Postures 3 and 4 with motion capture to respectively select and scroll items. And posture 1 is also used to open the checklist, while posture 5 is used to close the checklist. Now let's go ahead and take a look at the video. So at this point you will see that the initialization is happening. Posture 1, item validation. Posture 3, selecting a question. Posture 1 again, question validation. Stepping back using posture 2. Now using postures 1 and 3. scrolling items using posture 4, choosing the items again using postures 1 and 3, and you get the point. So I don't want to go through the whole video here. So now the second video, the checklist is going to be performed to answer 2 technical questions. In this video, the part manipulation is done using CyberGlove and motion capture. The first technical question is selected and answered by using a snapshot of an inspected part. A new technical question is then selected and answered by recording a video showing part assembly. So now let's go ahead and look at the second video. You will also see that there is an avatar of the hand. So the first technical question selection is done. The domain has been selected. The subdomain has also been selected. And then the question is presented. And when the question is selected, you'll see that the person is answering the technical question with inspection photo recording. I'll move it forward a bit. So now selection of a new technical question is happening. And the second question is answered by recording a video, as mentioned before. So I'm going to stop there in the interest of time. We'll move to the next one. So the third video is going to show how the haptic arm is used with the manipulation modules. First, a question is selected in the checklist. Then the video of the test is recorded. And to complete the multimedia documentation of the technical question, a comment is typed into the control PC, and the technical question is answered as seen, and the information is updated in the spreadsheet. So now let's look at the video for how that has been handled using the haptic arm. So at this point, the technical question selection has been done. Then the subdomain has been selected. So in this case, the mechanical domain and the subdomain has been selected, which is under the mechanical domain, which is modules. And the question is presented to the user. And at this point, the person is manipulating the object that's shown in the 3D environment using the haptic manipulation unit, and it's being recorded. So at this point, once all the recording has been completed, the person enters the answer back into the control PC, and that is recorded and stored back into the spreadsheet. So now if you want to look at what results were achieved using this particular experiment, almost 10 engineers were provided the ability to test this out, and the selected procedure for calibration was very successful. It took about 15 to 30 seconds for each user to calibrate the system, and once the calibration was done, the engineers were natural with using the interactive menu. The hand posture recognition was not sensitive to user changes because of the initialization procedure. So all in all, it was very encouraging, And it's probably based on the fact that they were engineers who were used to working with new systems, and the process included the calibration procedure. So from that standpoint, what were the conclusions and perspectives of the study? So this feasibility of the new paradigm for 3D immersive project review in an industrial setup has been tested, and a serious case can be made for using this in a variety of other checklist situations as well. Obviously, the experiment did not create a commercial tool, but it provides a proof of concept of how a system such as this can be used for interactive simulation and numerical data in an industrial setup. The architecture designed as part of this experiment was modular enough that it can be used for any other interactive checklist setup. Obviously, more research is necessary to change the text-based input to a speech-based input. In my personal opinion, that is one of the biggest issues with this, because the person has to literally stop their workflow, go to a different PC and enter their input. Um, and the engineers adapted to this new method quite easily. So this has a lot of promise. So with that, we will turn it over to you for question and answers. Thank you very much.